Have you ever just wondered what is actually going on inside the quote-unquote brain of an AI? For the longest time, it's basically been a black box. We know it works, and it works incredibly well, but we don't always know how. Well, today, we're going to change that. We are stepping inside the AI's mind with a brand new blueprint that shows us how it learns, where it can fail, and, most importantly, how we can build it better than ever before.
So, to get our heads around this, let's use an analogy. Think about the very core of an AI, its transformer layers, as an assembly line of painters. It's a pretty great way to visualize it. Each painter in the line gets a canvas, which is really just your prompt or your data. They add their own few strokes, their own special touch, and then they just pass it down the line. This keeps happening over and over, all with the goal of creating one big, beautiful masterpiece at the end.
So, let's step into the AI Painter Studio. This whole setup, this assembly line of digital artists, is pretty much responsible for the AI revolution we're seeing. But here's the catch. For years, we've been running this studio without a real instruction manual. We knew the final paintings were amazing, but we didn't fully get how each painter was contributing or what might happen if we started messing with the system.
Right. So to finally write that manual, researchers decided to do what any good engineer does. They decided to stress test the studio. They started asking some really simple but actually profound questions to figure out how this assembly line really works. They started poking and prodding it just to see where it would bend and where it would break.
So the first test was super straightforward. Are all of these painters absolutely necessary? What happens if you just, tell a few of them in the middle of the line to take a coffee break? Just pass the canvas along without adding any paint at all.
And the result was, well, it was fascinating. On the left, you can see what everyone expected. Total catastrophe, a ruined image. But on the right is what actually happened. It's called graceful degradation. Yeah, the final picture was a little less perfect, a bit fuzzy, but it didn't completely fall apart. And that suggests that there's some kind of built-in redundancy, especially in the middle of that assembly line.
Okay, so that discovery led to the next logical question. If skipping some painters isn't a total disaster, what about shuffling their order? What if the painter who's a specialist in backgrounds suddenly has to work after the painter who does all the tiny foreground details?
And again, the outcome was a real surprise. Shuffling the order was way less harmful than anyone thought it would be. It turns out all the painters kind of speak the same artistic language. They understand the canvas in a similar way. So even if they work out of order, they can still chip in and contribute without making a complete mess of the whole thing.
But here's the twist. This incredible flexibility, this robustness, it has a hidden vulnerability, a dark side, if you will. It means the whole system is super sensitive to its initial setup. If you don't arrange the studio just right before the painters even pick up their brushes, the entire process can go haywire from the get-go.
And this brings us right to the heart of the problem. Researchers found there are two very distinct ways this whole studio can fail spectacularly before a single piece of real learning even happens. These are the two critical failure modes of modern AI.
Okay, the first failure is called rank collapse. Just imagine every single painter on the line decides to just paint over the entire canvas with the exact same shade of gray. Poof, all the detail, all the information is completely gone. The second one is entropy collapse. This is when each painter gets obsessed with one tiny, random detail and just ignores everything else. Their attention gets stuck, the composition is ruined, and the whole system just becomes unstable and totally unable to learn. So, the crucial point is this, and the researchers put it perfectly in this quote, that initial setup is absolutely everything. Getting it wrong means you fall into one of those catastrophic failures, but getting it right, well, that's the difference between an AI that can learn and one that's basically dead on arrival. The big question became, how do we guarantee we get it right every single time? And that is where the big breakthrough comes in. The very same research that identified these failures also managed to create a solution. A blueprint, a clear, predictive map that tells us exactly how to set up our painter's studio for success, guaranteed.
And this amazing blueprint really just boils down to two critical dials that we can tune. The first is initial weight variance. Think of this as controlling how bold or how subtle each painter's first brushstrokes are. Too subtle, and you risk collapse. Too bold, and you just get chaos. The second dial is residual connection strength. This one controls how much of the previous painter's work gets preserved and passed on. It's basically the memory of the assembly line.
And this chart just illustrates the solution brilliantly. This is the blueprint. On one axis, you've got the boldness of the painter's strokes. That's the weight variance. On the other, you have the strength of the studio's memory, the residual connections. And you can see the danger zones so clearly. Too high variance leads to entropy collapse. Low variance with weak memory, and you get rank collapse. But right there, in that sweet spot, low variance and strong residuals, the model is perfectly trainable, every time.
So what does having this blueprint actually mean for the future of AI? I mean, it's about more than just avoiding failure. It's about fundamentally changing how we build these incredibly powerful systems. And it's unlocking a whole new era of development.
I mean, look at what this blueprint unlocks. We can now build models that are potentially way faster and more efficient. The development process itself becomes more reliable, more predictable, which saves a huge amount of time and compute power. We can confidently build much deeper, more powerful models without worrying that they'll just collapse during training. In short, we're finally moving AI development from being a mysterious art to a predictable, engineered science.
So we've basically gone from just crossing our fingers and hoping our AI painter studio works to knowing it will. We've traded all that guesswork for a guaranteed starting point. And that leaves us with one really exciting final question. Now that we have the blueprint, what new masterpieces will AI create?